Morning, everyone. So this time I'll be talking about aldehydes and ketones. If you're following along in the Timberlake textbooks, you'll be in chapter 14, section 1. In the Libre textbook, still in chapter 14, but you're in section 9. All right, so aldehydes and ketones. So the most important part about aldehydes and ketones is the carbonyl carbon. And the carbonyl carbon is the carbon that is double bonded to an oxygen. Um, and we talked before about differences in electronegativity. And if we look at the periodic table, we can kind of judge that carbon is a lot less electronegative than oxygen in terms of electronegativity. This means that carbon has a partial positive charge, oxygen has a partial negative charge, and there's an overall dipole moment. And we show dipole moments as like a cross arrow and going and pointing towards the more electronegative atom. This is going to become really important when you talk about reactions of aldehydes and ketones and um, kind of like the synthesis reactions that they participate in. So, what are aldehydes and ketones? Aldehydes are carbonyl carbons attached to at least one hydrogen. So, if you look at the structure at the bottom of the screen, you have your carbonyl group. It's attached to one hydrogen. And then this could be either an R group, like another carbon-containing chain, or it could be another hydrogen. But there has to be at least one hydrogen attached to the carbonyl carbon for it to be considered an aldehyde. For ketones, ketones are carbonyl carbons attached to two different carbons. So again, you have your carbonyl group, and then you have one R group and another R group. Now those R groups can be the same, they can also be different. Um, but again, the main difference between aldehydes and ketones is that aldehydes are a carbonyl carbon attached to at least one hydrogen. Ketones are carbonyl carbons attached to two different carbons. All right, so let's just look at a few structures and try to identify whether they're aldehydes or ketones. So this first one, we have a carbonyl carbon. It's attached to some carbon-containing group, but it's also attached to a hydrogen. This would make this an aldehyde. Similarly, we have a carbonyl carbon here that's attached to at least one hydrogen. So this automatically means that this is also an aldehyde. And then this last one, we have our carbonyl carbon. It's attached to two carbon groups. Then this is a ketone. When it comes to naming aldehydes, first you want to name the longest carbon chain. So in this case, we have, in this chain, we have 1, 2, 3, 4, 5 carbons. So we have pent. And then the suffix for this out for the aldehyde group is Al. So it's pentanal. Then we number the carbonyl carbon as number 1. So this gets the designation 1. And then we number and name all the substituents relative to that carbon. So this methyl group is at the 3 position. So then this becomes 3-methyl pentanal. And because the carbonyl carbon is at the 1 carbon, we don't have to have 1 pentanal. It's just assumed that the carbonyl carbon is at the first carbon. It's pretty similar for ketones. Again, you're numbering the longest carbon chain. So in this case, we still also have 5 carbons. Um, so that's where the pent comes from. And then this suffix for ketones is ONE or pentanone. And then we number the carbon, starting with the carbon nearest the carbonyl carbon. That was a lot of words, but basically, the carbonyl carbon would never get the designation 1 because you still have a carbon group to both the left and the right of it. So the carbon that is nearest the carbonyl carbon would get 1. So this carbon gets the designation of 1, leaving our carbonyl carbon at position 2 and our methyl carbon at position 4. So then this becomes 4-methyl 2-pentanone. So unlike aldehydes, you'll always have to include the number where the carbonyl carbon is for ketones, because again, the carbonyl carbon will never be at the end of the chain. There will always be at least one carbon to the right or the left of it.